Now let's continue to problem 3. Problem 3, you want to find the Taylor series for those functions. One thing that you can do is to take advantage of existing Taylor series that you know. In this case, this is the one that we are going to take advantage of. So now I copy the problem to this page. I also copy the Taylor this definition right here. Okay, and the reason I want to convince you that you should not go use the definition in this case, just think about this particular function, this particular one. So if you call f of x squared e to the 2x, now think about this. When you find the derivative of f prime, product rule will be applied, right? Product rule. And then you will have this result, 2x e to the 2x plus x squared times e to the 2x times 2. Okay, so this is just your f prime. And then f double prime, just imagine there's another product rule here, so it will be long. And f triple prime will be even longer, right? So therefore you can imagine it will be a terrible if you do it this way. So I'm gonna erase that. We don't do it that way. We are gonna take advantage of the results that we have from here, this one. And a quick review is e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on and so forth. If you can recall that in class, we try to make sure that everybody knows how to read formula. So in this case, x is just a placeholder. You should think of it as a box, right? A box. So with that introduction, let's go back to the problem that we have. If you can recall, I actually should have written this down. Oh, by the way, we say x is the placeholder. It's just a box. So it's going to be 1 plus x, which is the box, plus x squared over 2 factorial, which is the box squared over 2 factorial, and so on and so forth. Okay, so therefore, for the first one, e to the 5x, so what's inside the box is just your 5x. So you can quickly write down the power series of the 2 factorial and so on and so forth for this one. And if you use the summation notation, which actually I want you to use the summation notation, it will be 5x raised to power k over k factorial. Okay, so this is it. And for this, this guy is actually the interval of convergence is from negative infinity to infinity. So therefore, as a consequence, when you do the substitution, this is the same. Because the box, in this case, that means the box is less than infinity, greater than negative infinity. So in this case, it's 5x less than infinity, greater than negative infinity, which means this guy. Okay. Now for the next one, x squared e to the 2x. So what we do here is going to be x squared times, now you're going to treat this separately. So take care of this first. And we just show how to handle this scenario above. So it's summation k from 0 to infinity. Inside the box, that's 2x raised to power k. And here will be k factorial. And then after that, you just simply multiply this into the move that into the summation notation. The reason we can do that is there's no k here. This is 2 is just constant. X is has nothing to do with k, so you can treat that as constant and move it inside. So therefore, if I move that inside, that's what I have. So here I'll have 2 raised to power k, because that's what 2 to the power k. And here I have x to the power k, but keep in mind I have an x squared, so therefore you can have x to the k plus 2 divided by k factorial. Alright, so this is that one. The very last one is e to the negative x third x cubed. So in this case, the box is this guy. So you're going to do substitution. Is equal to summation k from 0 to infinity negative x cubed raised to power k over k factorial. Okay, oftentimes we want to rewrite that into alternating series, so that negative 1 raised to power k and x to the power cubed, and then raised to power k, which means 3k, 3 times k, and then over k factorial. Okay, so this is the example for this is the example that we got